Welcome, and this video is going to be a little long, so bear with me, but this video is going to look at linear inequalities and also interval notation. So inequalities arise when we don't have a strict equality between between a variable and its number. We might have an inequality. So an inequality just compares the variable to a real number, and so from that comparison, right, it could be that, we know it is greater than, less than, not equal to, but maybe possibly equal to this number, right, when we're looking at a variable. And so when we talk about what a solution looks like to an inequality statement, it's often a range of values. And to communicate that range, we use a condensed compact notation in mathematics called interval notation. And so you can kind of see I have the overall format sketched out here, but it really consists of 5 symbols. So on the two ends, there's a closing symbol. We'll talk about what goes in those closing symbol. In the middle are boundary values, so we communicate the left-hand boundary and the right-hand boundary. And then in the middle, there's a comma to kind of separate the numbers so that we just don't read the numbers together. So it's really those 5 things that you need to write in interval notation. So boundary values are those that we see, we go from one end to the other end, and we see, they are called boundaries because we can have any value, or sorry, let me repeat that. The variable can take on any value between the two boundary values, anything in between, all right? And so that's why we just delimit it with those n values, and then the boundaries themselves, though they can be a little tricky, sometimes they're included in that range, sometimes they're not. And so to delineate the difference, that's where we have 2 different forms of closing symbols. So if that boundary is included, meaning that the variable can be that value, then we use what we call a square bracket, depending on, which side we're on. And then if that boundary value is excluded, meaning the variable cannot be that value specifically, we would use a parentheses. Okay, and so some examples would be these. So if we look at the first one, we would say this as x is less, or is greater than, my bad, is greater than 4. The inequality always opens towards the larger value, and so x is greater than 4. When we see that expressed on a number line, I always put 0 on my number lines, just for a point of reference. Here's 4, and then we would say, okay, well, it can be anything that's larger than 4, most certainly. Let me do that in a different color. So anything larger than 4, most certainly. And then when we say that, so here, if it's greater than 4, that does not include 4. And so I would use an open dot for that, meaning that value is excluded. If it was included, I would use a filled in dot. This notation is acceptable. You can also use a parentheses for that, and then extend forever to the right. Okay, and so then this graphical form, I find it's really easy to get the interval notation from it, because I can see, okay, the left boundary of my interval, right, what I have drawn in blue is our interval. The left boundary would be 4, which is excluded. And then how far to the right do I go? Well, forever, and we communicate forever using infinity. And infinity is a concept, not a number, so we can never include it. And so that's always parentheses. Okay. Next one. So I would read this as -3 is less than x, and or I would say which is less than or equal to 1. Okay, now you could probably get the interval notation on this without going to a number line, but just for completeness sake of following instructions, I'm going to show, okay, so here's -3, here's +1, and at 3, so the values of x are represented by this line I'm drawing, and they can be anything that's bigger than -3, so x is so negative 3 is less than x, so x is going to be bigger, but x is also less than 1, so it's anything in between here, but it does not include 3, negative 3, and it does say specifically equal at 1, so I can have a filled in dot at 1. Okay, and now here we can very clearly see the boundaries being negative 3 on the left, 1 on the right. 1 is included, so I would put a bracket there, square bracket there, and then a parentheses at minus 3 because that value is excluded. All right. So 5 symbols for interval notation. The values for x or a variable can be anything in between. Okay. Now, as you might imagine, we're involving x. We just got done talking about linear equations, and so we can talk about linear inequalities, which is pretty much a linear equation just with an inequality symbol. So you have the same sort of format, so x plus b and then box, and then the box can be, any one of those symbols. And so process is the same. I'll let you read it. The one thing that I want to stress is at the end, when you're trying to isolate the variable and you need to get that coefficient to be 1, if you end up multiplying or dividing by a negative, the inequality reverses direction. Okay, let's see that actually in our first example. Okay, so in our first example, right, we would need to get q's to the same side. So I'm going to subtract 7q just for fun. I could rearrange it if I wished. Okay, so I'm going to subtract those, and then let's say I'd end up with negative 4q is greater than or equal to negative 23. Okay, and so then I would isolate q by dividing by negative 4. Okay, and then q is now less than or equal to, I divided by a negative 23 over 4. Okay, and I'm going to leave it as a compound inequality, or a improper fraction rather. And so putting this on a number line, again, maybe you need the number line, maybe you don't, but it does say, graph its solution on a number line, so we're going to follow the damn directions. And here is 23 over 4, it's about 6. And so here I'd have saying q is less than, so q is less than 23 over 4 or equal to, so I have a filled in dot. And so my interval notation would be left boundary is all the way off at minus infinity. Right boundary is 23 over 4 with a bracket. Okay. All right. There we go. Next one looks a little bit more complex, and I'm going to go through the steps a little quickly. If you need to slow me down, that's fine. Okay, so first thing, just for clarity, I'm going to make this into plus a negative 7. Okay, just so I'm distributing the right thing. So I'm going to do 9h, distribute a minus 7 to both of those. I'd get minus 14 plus 7h less than 8h plus 88 plus 8h. Okay, simplify each side, so I'd have 2h minus 14 less than 16h plus 88. Okay, and what I'm going to do is a little unorthodox. I'm going to subtract 2h from each side, and also I'm going to subtract 88. So what I'm doing is putting everything, all the constants on the left, all the variables on the right. So I'd have 14h on the right hand side, and on the left would be 102. And so then divide by 14 to both sides. 14, and that does not divide nicely, but they both have a 2 in it, so I'm going to write that as 51 over 7 is less than h. Okay, and so then if I put this on a number line, right, because that's what the instructions say, and I'm going to follow the damn directions. Here's 0, and here is going to be 51 over 7, which is about 7 and change. So it says h is a number that is larger than this. You can rewrite it if you wish. H is greater than 51 over 7. That's fine. And so I'm going to do, I can't have that number, but I can have anything larger. So my interval notation here would be 51 over 7 off to infinity, and I would be done. All right. So a little bit longer video. Thank you for staying with me, but hopefully this is helpful as we start looking at inequalities, graphing them, and then also using the interval notation in the communication of the solution.